Hello everyone, and welcome to today's webinar, Feeding for Profit, How Leading Growers Are Saving and Making Money, brought to you by PlantProd. I'm Robin Sitberg of Meister Media Worldwide, publisher of Greenhouse Grower Magazine. Thank you so much for taking the time today to learn more about how to use plant nutrition to achieve plant characteristics that are optimal for the market. Since bigger is not always better, it's important to know how to use the correct formulation for each growth stage with the right micronutrients and appropriate chelates. This session is scheduled for 1 hour, and we intend to honor your time commitment by keeping it as close to that time frame as possible. We will have some time for some questions and answers after the presentation. So if at any time during the presentation you'd like to ask a question, type it in the question pane at the lower left panel of your presentation window and click Submit. Your question will go into a queue, and we'll do our best to answer as many questions as we can at the end. Now I'd like to introduce our presenter for the webinar, Jim Zablocki, Technical Sales Manager for PlantProd. Jim has more than 36 years of experience in the field of plant nutrition and fertilizer research, including product management, sales, supply, and development in North America and Europe. Among his areas of expertise are fertilizer characteristics in production and plant response. He's worked as a plant nutrition expert with businesses of all sizes, from large multinational corporations to privately held startups. So now I'm pleased to turn the program over to Jim Zablocki.
Thank you, Robin, and thank you everyone for joining us today. I appreciate the opportunity to take a few minutes to spend with you and speak with you about feeding for profit. And as we go forward, this hopefully will not be too complicated, and we'll keep this as brief as possible, but hopefully as informative as possible as we go forward. So with that in mind, I would just like to welcome everyone and hopefully keep you awake for the next few minutes as we speak, and hope you learn something along the way. So what I want you to do right now is just for a minute is just think about, take a moment and sit back, think about the changes that have occurred in the last 50 years in all our aspects of life. But specifically, let's just think about what we've done in plant nutrition in the last 50 years. The following presentation is going to see how these changes have affected plant growth and economics and efficiencies. So with that in mind, if we would just go to the next slide for a minute, this just kind of puts it together in a better position. We've changed our diet from humans considerably over the last 50 years as far as what we do and what we eat, and the things that we thought were good aren't necessarily were the best choices at the time. Plant nutrition's pretty much followed that same path, differently in many ways, but in some cases quite similar. We've learned over the years that we don't need to feed our plants nearly as much as we used to. If you go back 20, 30 years ago, it wasn't unusual for us to be feeding at 400 or 500 parts per million of fertilizer. That was a norm. Today, anyone who would be feeding that much would have plants that would probably be 5 feet tall. The other thing that we've learned over time is micronutrients are as important, in many cases, more important than the actual macronutrients, which would be, we know normally as NPK. And we're going to talk about, in the next few minutes, the importance of what micronutrients do for us in plant nutrition, and more importantly, how it can increase efficiencies that we would never think of previously. One of the things that's happened over the years is the introduction of chelating agents. Now, chelating agents are something that are used almost exclusively in our industry and rarely used in the agricultural industry. But chelating agents are very specific to horticultural plant needs, and we'll talk about that next. But just recognizing that we're going to be talking primarily about chelating agents, and usually chelating agents are used as a micronutrient in fertilizer solutions. Oops, I'm ahead of myself. I apologize for that, folks. One too many slides. Now, one of the things you want to learn about chelating agents is that they provide a much more stable solution for a micronutrient. What a chelating agent is, it's an organic compound that forms a ring around an ion like zinc or iron or manganese. And that delays the precipitation or the leaching of the micronutrient into the soil media, and more importantly, out of the soil media. Previously, we've always used sulfates, if you go back far enough, and sulfates were brought in primarily from the agricultural industry. That's where micronutrients first got their place. we as an industry adapted that micronutrient technology using sulfates in our business to add micronutrients to the water-soluble fertilizer blends that we made. One of the problems with sulfates, though, however, is that they only work effectively at very low pHs. That's one of the primary challenges that we have with that. The second part of a sulfating compound is that they're very soluble. In soil, in a field soil, like a farm, things leach very little, very slowly, if at all. But in a soilless mix, things leach relatively quickly. The challenge with that is, because of that, a sulfate isn't taken up by the plant fast enough before it leaches. So though you may be adding sulfates to a fertilizer solution and eventually to the pot, the plant doesn't have the opportunity to take up all those sulfates, those micronutrients that we're discussing here. And in turn, they leach out of the pot before the plant ever completely gets the full advantage of all those components that we added. Chelates change all that. The other thing that happens is that as time has gone on, we've learned that there's different types of chelating agents. The most common chelating agent that's used in our trade is EDTA. If you ever pick up a bag of fertilizer and you look at iron, normally iron is the primarily chelated micronutrient in a bag of fertilizer. It's mostly available at a pH below 6. So if you're trying to grow a crop above 6, that EDTA iron isn't available as readily, or if at all, as your pH rises, which is not unusual in soilless growing media over a period of time. pHs tend to creep up over time. So what we've done over the years is we've learned that there's other chelating agents besides EDTA. There's chelating agents called DTPA and EDDHA. This allows the micronutrient to be more available at higher pHs as compared to traditional EDTA. They're more expensive, and we're going to talk about that in a little bit later, but it allows you to grow in an environment with a higher pH, and more importantly, if you have high bicarbonates or alkalinity, both of those which contribute to the limiting factor of how well a micronutrient is able to be taken up into a plant. So that, with that said, a standard water-soluble fertilizer that doesn't have all their micronutrients chelated, or more importantly, using a different type of chelating agent depending on your water properties and your soil media, you're not getting the total bang for your buck, so to speak, as you go forward. So what we're going to say is we're going to end up using less fertilizer, which is kind of hard to understand coming from a fertilizer company. But the idea is you can actually use less fertilizer and, more importantly, save money at the same time. And you're going to grow a better plant, and we're going to show you how that works. By doing that, you obviously have less of an impact on the environment because you're leaching less and you're using less fertilizer in the grand scheme. You're going to feed at a much lower concentrated rate on a continuous basis compared to what you're doing in the past. But the key part of this conversation is that you're going to have a higher chelating agent package in your water-soluble fertilizer than what you've had previously. That's the key part of growing with less fertilizer over a period of time, is having the right chelating agents in that fertilizer. So yes, we are going to actually use less fertilizer and grow a better plant, which is, as I stated earlier, hard to believe coming from a fertilizer manufacturer. So, micronutrients and solubility. I mentioned earlier that sulfates leach very quickly and most commonly aren't taken by the plant fast enough to get the full bang for your buck. The other thing about chelates is that they're something that is be said about, they're about 5 to 7 times more effective of being taken up by the plant than a sulfate ever would. So you're getting more of what you put in the fertilizer, into the media, into the pot. And you would not notice that normally because you're just assuming because I've got so many parts per million of iron or manganese or zinc that all goes in. Unless they're all chelated and unless they're using various chelating agents, you don't get all that. The most expensive chelating agent that's used in the trade is EDDHA. And if you look at that slide on the bottom, you can see the difference in cost, which is, on a per-ton basis, is astronomically expensive. Now, granted, you're not using much of that in a bag of fertilizer. To give you an idea, in a bag of fertilizer, you'd be using about 11 grams of a chelating agent at any one given time. So the cost is relatively small increase to what the fertilizer finished cost would be, but the effectiveness is significantly different compared to what you would get from, say, a sulfate or even just something as simple as EDTA. So as you go with these three chelating agents that you see on this chart, there's EDTA, which I mentioned before, that's effective to around 6, but as your pH increases, you need a chelating agent like DTPA or better yet, EDHA. What we do in many cases uses all three to adjust the pH range appropriately, so regardless if you're growing a calipicoa or a geranium on the same bench, everybody's getting micronutrients at a proper level without using excess amount, or more importantly, have to supplement, which a lot of people end up doing because they don't get all the effectiveness from their micronutrient package from their fertilizers, so they have to supplement. So, the other thing I mentioned before is that as your pH rises, or more importantly, as your bicarbonates are increasing in your water, the effectiveness of these three standard chelating agents become more and more important. Most people have a pH range they like to grow in between 6 and 6.5, but it's not unusual to be above 6.5. Stated earlier that EDTA isn't just doing everything for you as it possibly can because your pH is getting too high for that EDTA chelating agent to do it's effective as it should be. So as you go forward with these other three units, the other two chelating agents, you see the differences that it move forward. Better yet, this next slide probably explains it a little better. So you can see from a normal pH range, now nobody would obviously be growing at these pHs of 1 or 2, that's rather silly. But as you're creeping up towards 6, as you see the EDTA starts falling off, then the DTPA is more effective. More importantly, as you see that EDDHA is where you really start to see the differences as far as how effective that's being taken up by the plant. What we've also started doing is we're evaluating, we had a group of people that went to Holland last year to look at how well these chelating agents work. And there's this new one called HBED that's newer for us, and we're evaluating it internally as we speak right now to see if it has effectiveness at higher pH. Normally we wouldn't be getting this high, but the key point of it is if it's effective at the key ranges we're looking for, we're always looking for opportunities for something to add to the arsenal of weapons or tools that we offer to the industry to make sure we're growing the proper plant with the least amount of inputs as possible. So you can see there's lots of different chelating agents that most people aren't aware of when you look at a bag of fertilizer. So it's just something to be recognizing that's in the trade. So what you'll see over time is plants like calipicoa and geraniums can grow on the same bench at a higher pH and still get that dark green calipicoa or pansy or petunia that you're aiming for, that you're struggling with. Virtually everyone does in the trade because you need to grow at a lower pH to get the iron available. But if you use the appropriate chelating agent that's more available at a higher pH, you can grow that plant, the calipicoa, that pansy, that petunia, and get that dark color even at a pH of 6 or 6.5, which is just different for us than we normally look at. What this also allows us to do on young plants, we really have to be conscious of not over-fertilizing. And traditionally what we've always had to do previously in order to get the appropriate amount of micronutrients to that plant is we had to increase our feed because it was all bundled together. So we would have to feed it 200 parts per million sometimes to get all the other micronutrients that are in that bag at an appropriate level to that plant. But that's the worst thing you want to do on a young plant because they're very, very sensitive to ECs or salts. At that stage, any stress you put on that plant will either cause injury, stunt the plant, or potentially even kill that plant or allow pathogens to enter in because of an injury that's gone to the root tip. So you're going to increase your efficiencies on your young plants. We're talking about a seedling or an unrooted cutting. As you go forward, those nutrients are going to be available at very low rates. I mean, you can go down to 25 or 50 parts per million with an elevated minor micronutrient package and still look good on growing on a bench with young plants. So it's something key that you want to recognize with this. And one of the reasons why I bring all this up is that when you think back about how things have changed over time, there was a time when we used to use sodium lights when we were supplement with lighting. Everybody used sodium lights. Now all of a sudden you would be kind of looked at oddly if you even wanted to purchase a sodium light. It's all going to LEDs. They're more expensive, but they're far more effective. Just like with light, just like micronutrients and chelating agents, there are changes that have come in the trade, and I think it's something that you'll need to take a look at as you move forward. So we talked about iron-hungry plants, things like petunias and calipacoas, how you can grow them at a higher pH, even with higher bicarbonate levels. And if you have a product like, in our case, Plant Tech Solutions, which is a specific line of product that we have that has these elevated nutrients that I spoke about previously, will make sure that you can grow the plants that you're looking for at lower rates of feed. So what that does for you, though, is it allows you to increase efficiencies in your facility, not just by using less fertilizer, but actually you're going to grow a better looking plant. You're not going to grow a tall, leggy plant. It's easy to grow a big plant, but there's a lot of space in between. What we're looking for in our trade is a tight, full plant. It also allows you to use less plant growth regulators, or PGRs. So we're not overfeeding the plant and then trying to hold the plant back because we've ever fed it too much, so we now put on a lot of PGRs to reduce the height on that plant or reduce the internode length. So we can many times completely eliminate PGRs by just going with these much lower rates of feed. By doing that, you also get a tighter looking plant, and it's a firmer plant than what you would normally have. It's not that soft growth that we quite often receive. So we're going to have far less breakage than what we would normally see. A mum is a classic example of how if the plant gets too big and you try to ship that plant, you have a lot of breakage. What that means for you is you're loading a truck, you're going to have less breakage. Ideally, you're going to have more on a rack as you go forward. What eventually could happen is you could actually lower freight. So you're gaining in a lot of places that you would not normally expect to gain by just feeding less with the right type of fertilizer. You can increase those efficiencies both on costing to the input cost into the material, but also the finished plant is going to do better for you in the end. And simple things as freight increases, or your freight rate actually drops because you've got more plants on a truck. Where this also comes into play, as I stated earlier, is on young plants. Young plants are very sensitive to all the things that we talked about previously, and that early stage of plant growth is something that we just sometimes forget. One of the things that we don't realize is that young plants need more micronutrients at an earlier stage than we normally thought. Most of these micronutrients have a significant impact on rooting. And you wouldn't know that by doing a tissue test on a plug or a rooted cutting, but the root system would tell you a significant different story if there's elevated levels of chelates. They actually cause the root system to grow better and be fuller and thicker in a shorter period of time. So on a young plant, you'll actually turn that flat, that crop over, that bench over in a shorter period of time by getting better rooting early. Because really when you're growing a seedling or a rooted cutting, all you're trying to do is make root mass at that early stage. You're not really looking at that much top growth in that early stage. But something as simple as zinc, which we never would even think about, will have an impact on rooting, does. It has a significant impact on rooting. And micronutrients, as you can see in this next slide, will impact rooting just by increasing the minor element package. Again, we always focus on the top of the plant quite oftenly, and sometimes we forget on young plants that's the root system that we're really aiming for, and trying to make sure that we have a well-developed root system, because by having a well-developed root system early, when we transplant to its final pot, whether it be a hanging basket or a 4-inch or a 6-inch container, it will take off faster. The healthier that seedling is or that plug is going into its final stage, the quicker the turns become. And turns are everything in our trade, which again increases efficiencies. So if I can turn that plant better just by getting a better root system, that's making money for me right out of the gates. So it's something to keep in the back of your mind as we go forward, that lower rates of fertilizer with the appropriate amount of micronutrients in that solution will give you the root system that you're looking for and a finished plant that you hope to get. And we're talking about something as low as 100 parts per million for most of your production cycle after it leaves the plug tray. Now, granted, I said earlier, in a plug tray, we don't even want to be growing 25 or 50 parts per million once we start fertilizing. But after that stage, we can grow a very, very healthy plant at 100 parts per million all the way to the end. As a matter of fact, what a lot of larger operations will do is they will purchase a water-soluble fertilizer from us with no trace elements or no micronutrients in it at all. They'll just have the NPK, potentially calcium and or magnesium in that fertilizer, and then they'll feed with a separate micronutrient package to allow them to elevate their micronutrients regardless of how many parts per million of feed they're going with. In many cases, it's 100 or even less at many times. I've seen people grow a hardy mum at 75 parts per million, and the mum is beautiful. The key part of it is having the elevated micronutrient package. Now, with that in mind, it's real easy to get a plant to get bigger. It's real hard to get that plant small. So sometimes you may need to actually elevate your fertilizer rates to 150 or 200 parts per million of fertilizer as the plant needs it as you go forward. But that's a choice that you have to make. Normally you won't need to do that, but you can do that and still grow a healthy plant. The key part of it is the bulk of the production is at a much lower rate than what you're normally used to, and that's at 100 parts per million. So just something to keep in mind, that you may need to raise your rates as the plants mature, but it's not necessarily the case on all plants and in all situations, provided you're using the right NPK fertilizer with the right micronutrient package enclosed in with that. So it's something to keep there. Solubility is another piece of this conversation that comes in play, especially when you're going with low rates of fertilizer. What I mean by solubility is that a lot of times we'll buy cheaper fertilizers because we just look at NPK as NPK and all the other micronutrients that come with it. But there's a lot of impurities that come quite often with the overseas cheaper fertilizer that's brought into the industry. And by doing that, there's a lot of ingredients in you that you don't want that contributes to your EC level that you don't even know about. We're going to talk about boron and sodium in a little later that comes quite often with the raw ingredient that you're not even aware of. But more importantly, all these things affect the solubility of the fertilizer. So if you make sure when you're purchasing raw ingredients, as we do in our organization, we want the purest material we could possibly receive. But we also test every batch of fertilizer that we get in to ensure the fact what they're sending us is actually what we want, and there's nothing inert in there or other contaminants in there that shouldn't be there. So we screen every product that comes through. The other thing that we do is we want to ensure that every product that we purchase is extremely soluble. So much of the agricultural fertilizer that's used in agriculture doesn't work for us because it's too coarse and doesn't go in the solution properly as smoothly and easily that you would expect to see from a water-soluble fertilizer. Yes, it's cheaper, but by the fact that it's cheaper, that means that you're going to have product that doesn't go in the solution and settles at the bottom of the tank. The last thing that we do is we grind the bejesus out of it, and the bejesus probably isn't the right word to be describing it. We have a technology that we use that we grind the product to as fine as possible, because the finer the grind, the more solubility you have as you go forward. The coarser the prill, the more challenging it is for that prill to go in the solution. So the quality of the fertilizer coming into us that eventually makes it to you is a significant difference in how solubility affects your plants. We had the opportunity to be part of an organization where we can purchase raw ingredients directly from the manufacturer from a vertical integration that we have. So we make sure that all our material has very, very low salts, and we make this product right here in North America, in Canada specifically. So we have some of the highest quality mineral mines in the world as far as what we work with. It's something that we're quite proud of. One of the things I talked about earlier was contaminants. The two most common contaminants that you'll see in a raw fertilizer is boron and sodium. Now, you're going to sit there and say, well, I look at my label on my bag of fertilizer and I know how much boron's in there. All you're seeing is how much the water-soluble fertilizer manufacturer has added more boron. They're not necessarily testing the various components coming into their facility to see if there's boron as a contaminant on that product. We test them all to ensure the fact that if there's any boron, it's incredibly minimal or there's no boron whatsoever. The same thing holds true with sodium. Sodium doesn't bother plants that much, but it contributes to salts, and if you get enough sodium in your fertilizer, you start competing with potassium and calcium and having the same positive charge, where those two components can't get taken up by the plant well enough because they've got too much sodium present. It also becomes a factor if I'm living near the coast, where quite often sodium leaches into the groundwater from the ocean, which increases the sodium levels in your groundwater, your tap water that you're watering with. So a lot of people are very, very sensitive to how that things like boron or sodium levels can be. If I'm growing something that's not that a lot of people do, but if I'm growing bromelates, for example, they can't tolerate any boron. So it's important for someone who's growing bromelates to recognize that they can purchase a fertilizer with virtually no boron present, because otherwise they could have serious implications by that plant by having excess boron that really shouldn't be there. So it's just something that you should take in consideration as you go forward about when you're purchasing fertilizer, making sure that there's no contaminants, and more importantly, everything is in the bag is actually stated on the label and nothing extra that you're getting that you shouldn't be getting. What that also means is that when you have fertilizer that's completely soluble, you have no waste in the bottom of your injector tank, which would seem rather simple. But more importantly, when you have sediment or precipitation on the bottom of the injector tank, you have no clue what that fertilizer is or what that was, what that component was that dropped out. Was it the phosphorus? Was it the iron? The only thing that's going to know is the plants. The plants aren't going to tell you until it's way late in the system to find that out. So it's key to make sure that when you open a bag and drop a bag of fertilizer in your concentrate tank by your injector, that everything goes completely in a solution and everything in that tank goes into the plant. So you have no nutrient waste and simple things as injector lines, drip tubes, all that stuff. None of that stuff clogs. So you don't have to mess around cleaning those out over time, because that's just a pain in the neck to be dealing with. You don't have to wait for the fertilizer to go in a solution. If you go back years ago, everybody wanted you to use hot water to put your fertilizer in solution. I don't know too many people that do that anymore, but that was a standard method of explaining how make sure all your fertilizer goes in a solution by using heated water first. A good fertilizer that's extremely soluble shouldn't have to go down that route. And more importantly, nothing's missing because of poor solubility, as we talked about earlier. So it's just all these things that solubility helps in making sure you get the proper plant growth. The other aspect is we talked about young plants earlier. And when you're looking at young plants, if you're feeding at 25 or 50 parts per million, you're having sediment occur with your fertilizer. It's even more critical to that plant as far as all the solution that you put in that injector is feeding that plant on a given basis. Because just a small quantity of product precipitating out in the bottom of your injector tank will have a huge impact on a young plant. It's much different in an older plant than a young plant. Just like kids and adults are different, plants are the same way. When they're infants or they're small, they're very sensitive to hot air ECs or imbalanced ECs, imbalanced nutrients. So sediment and precipitates that occur during feeding process on a young plant even becomes more of a factor. So something to keep that in the back of your mind as you're going with a seed tray or a plug tray going forward. We have some of the highest solubility in the industry. It always ceases to amaze me because of all the industries I've worked with and where how well Plantex or plant prod fertilizer goes in a solution. I've just never seen anything like it. It dissolves completely the way it works, and you have less downtime and less clogged nozzles and all the things that I was talking about earlier. So it's just something that we're kind of proud of in our trade, and sometimes we kind of take it for granted, but I always realize that some people just don't realize that, you know, the stuff on the right, I saved $1 on a bag, but look at the stuff on the right with the sediment on the bottom of that jar. Plant Prod or Plantex fertilizer just doesn't have that problem. It's a very, very soluble material. One of the reasons why people love us so much is I talked about how we grind the bejesus out of it. Well, that bejesus word is turbo milling. And what turbo milling is, it grinds down the product to a very precise particle size. The finer the grind, the more surface area you have to the fertilizer itself, which means is that everything goes in a solution faster and more efficiently. You also end up with a much more homogeneous product when it's ground that fine. Not as much of a big factor if you're using a bag of fertilizer all at once at a time, but if you're a smaller organization or just have a smaller injector for whatever reason and you're pre-measuring the fertilizer out of a 25-pound bag, then you want to ensure that when you take that scoop of fertilizer out of that bag, that everything is exactly the same. So this turbo milling process that we use within our organization, which we've patented many years back, is something that's unique to us. It ensures the fact that we just stay with that solubility issue all the way going forward. So it's just very helpful to recognize that there are differences in fertilizers and how well and how soluble they all are. One of the things that we talked about before is how larger operations will use an NPK with a calcium, potassium, magnesium component in the bag and then add their traces separately. Many or most of the top 100 growers in North America go with that program with us using either Plantex or Plant Prod fertilizer, recognizing that we can do all these different things for them and grow the plants that we're talking about at actually lower costs. So it's something that if a large operation is looking at it, there's a reason why they use us. It's not just for plant performance. It's based on economics and logistics. So there's a lot of factors that come into play when they're looking at when they want to use a fertilizer and what kind of fertilizer they're using. And it's just kind of look proud of that aspect. One other thing that comes into play in water-soluble fertilizers is the use of phosphorus. We knew years ago that triple 20 was a standard operating procedure when we fed with fertilizer on our plants. We also learned not too many years ago that too much phosphorus stretches the plant a lot. So we ended up realizing that we're getting taller plants, thinner plants, weaker plants than we should have. So over time we've lowered our phosphorus usage. What we've done is we've gone from a 20-20-20 to a 20-10-20. Now we're even much, much lower than that. We've learned that we can grow a plant at 2 or 3 parts per million of phosphorus and still have the ideal-looking plant. Plants just don't need that much phosphorus in our trade. They need phosphorus. Zero phosphorus is not a good idea, but we don't need nearly as much phosphorus as we thought we did. The other thing that comes into mind, and we keep coming back to the zinc conversation here, excuse me, zinc and iron are actually impacted by high levels of phosphorus in your solution and in your media. If you have high levels of phosphorus in your water solution and in your media, it starts tying up the zinc and the iron. They actually form a precipitate and will precipitate out. So all that conversation we talked about micronutrients earlier comes into play by using too much phosphorus, because you start adding phosphorus at an excessive level, and all of a sudden the key elements that we were trying to get into that plant, like zinc and iron, are taken away and precipitate out because we're using too much phosphorus. So just other benefits of not having too much phosphorus to the plant beyond the fact of what it does to stretch, it also impacts part of your micronutrient package. So it's just something to keep in the back of your mind going forward when you're looking at a bag of fertilizer. How much phosphorus do you actually really need? I'm just saying you need a lot less than you think you do. And on that note, what we're going to say is thank you. And there's something I always want to share with you about this slide. The younger people would appreciate this in the audience. You can get a tattoo by a cheap tattoo artist, but you're not necessarily going to get what you're paying for. And in always the case, there's always someone who will make something cheaper for you, but is that exactly what you were looking for in the end deal. You want to get the best performance at the least cost, not the least cost at the least performance. So with that in mind, I want to thank you for the opportunity to speak with you today. And if you have any questions, now's the opportunity to go forward. Thank you very much.
Okay,
Robin,
thank you, Jim. Oh, okay. Thank you, Jim. As Jim said, we would now like to open the floor for questions. We have gotten a few in from the audience, but if you have a question, please type it into the questions pane at the bottom left of the control panel and hit send. So our first question is since sulfur is important for plant nutrition, wouldn't sulfates contribute?
In the grand scheme, no, and there was a thought years ago that you wanted to add more sulfates, but by adding sulfates, first off, as I stated earlier, that iron sulfate or that zinc sulfate or other sulfate we're using, a lot of that's never gotten into the plant. It actually leaches out before the plant ever has the opportunity to take it. So that's item number one. Item number two about that aspect is the amount of micronutrient zinc sulfate or manganese sulfate that you'd be adding is so small it would contribute very little to the sulfur needs of the plant at that stage. If you wanted sulfur, you'd add more sulfur. Traditionally, plants aren't too deficient in sulfur to begin with because they get sulfur from various aspects, both from your water, from the media, and from some of the components that come in the fertilizers. But sulfates just aren't going to give you what you're looking for if you have a sulfur deficiency. Thank you.
Okay. Okay, the next question is, my plants seem to grow fine using cheaper fertilizer, so why should I change? What results would I see?
That's always a question that comes about because, I've been using XYZ for all my life, and my grandfather did that, or where I worked at before, we did that, and it was all good. What's the point? You can go with cheaper fertilizers. One of the things that I mentioned early in the conversation is it's not the cost of the fertilizer, it's how much you have to use. If you have to grow a plant at 150 parts per million to get a proper looking plant, that's fine. But if I can do that at 100 parts per million, that means I'm using 50% less fertilizer. I know you're not saving 50% of your cost on fertilizer by going to a cheaper fertilizer. You might be saving 5 or 10%, but you're not saving 50%. The key is what's in that bag of fertilizer when you make that purchase. So if you use a better fertilizer and use less of it, you're actually saving money in the long run. So cheaper isn't always better. It's just more of a case of cost and use and what's your final use per pot at the end of growing season. So it's something that you always got to keep in mind when looking at fertilizer costs is what's in that bag and how will that plant respond at low rates of feed. Thanks.
Okay. One of our viewers has asked, I live in an area with high sodium or boron in my water. How can I find out if my fertilizer is contributing to a potential problem?
There's tests that can be done. The best thing to do is, ideally go to your manufacturer and ask them that. And if you want to make sure that they're physically testing the raw ingredients coming in like we do. A lot of manufacturers don't do that. I suspect the vast majority of them don't. So the key part of that is request a sample of a test from their fertilizer to make sure that there's no additional sodium and boron other than what's stated on the label. The other thing is you could take your own sample of fertilizer and send it into a lab and have it tested to ensure the fact that there's not additional sodium or boron. It's just whatever you're most comfortable with. Obviously, if you do it, there's a cost involved in it, but you also will find that you're getting an honest answer rather than a fudged answer from the manufacturer. Something that we do with anyone, we'll share all that information with them. But a lot of manufacturers don't necessarily do that, so that's the best way to approach that.
Okay. Our fourth question, I guess it is if I wanted my supplier to include EDDHA, how much would that increase the cost of the fertilizer, and can you make custom blends?
Yeah, the cost of adding EDTA, the question was EDDHA?
EDDHA, yeah.
Yes. The cost is relatively negligible, but there is an increase in cost. It would be, I'm just going to throw out a guess here. It's maybe, I think I have that information somewhere. I'll have to find it here. I'm just going to say it's probably 10 or 20 cents a bag more by adding EDDHA to the bag. It might be a little bit more than that. I'm not quite sure. There was a second part to that question, too, wasn't there?
Yeah, can you make custom blends?
Oh, yes. In fact, we kind of pride ourselves on the amount of custom blends we have, and our standard charts that we show to the trade, there's probably 20 bags, 20 different types of fertilizers. In our system alone, we probably have at least 400 SKUs of different custom blend fertilizers that we sell throughout the world. not just in North America, but all over Asia and Europe. So to answer the question, yes, we do it all the time for all sorts of people. The only thing that we do is we have a 2-ton minimum, which is relatively small, to make a custom blend. So yes, if you wanted to have more zinc or no zinc, or you wanted to have components that are kind of odd for us, we would do all those things. It's a very standard operating procedure within our organization. We're quite flexible on that aspect.
Okay.
Good. Thank you.
Good. How do chelated micronutrients differ in efficiency of feeding from liquid organic, such as fish fertilizers, that contain a spectrum of micronutrients?
Well, chelate, I kind of get that. It would depend on how the micronutrient is, what state it's in an organic form of fertilizer. Quite often, organic fertilizers aren't readily available to the plant like lack of a better word, a chemical manufactured fertilizer. So there has to be some breakdown of an organic in order to get into the plant, which is okay if you're not watering on a daily basis. But if you are, that means a lot of that never gets to the plant. It goes back to the original thing that we talked about. It's not that I want to compare an organic fertilizer to a sulfate, but there are similarities. Organics work great in soil, where I can place it on soil, and over a period of time, that product will break down, and the plant will take up the appropriate nutrients. Some things break down faster than others, but the general rule of thumb with an organic is it's a slower release process than the instant of a very soluble chemically manufactured fertilizer. So chelates make sure that when you put that fertilizer on, it's taken up by the plant instantaneously. Sulfates, we talked about the challenges with that, and organics would be kind of fall in that same category, where if it's taken up by the plant, that's great, but there's a good chance not all of that you just put in that solution is going to be taken by the plant, and your next watering you're going to lose it all because the plant can't get it fast enough, because we water our plants so frequently in our trade, mainly because we're growing in soilless media.
Okay. And I think this person is asking for maybe suggestions, but they said, what about low phosphorus in vegetable growing?
Vegetables are a little different. Now, if you did a finished if I'm growing cucumbers or tomatoes, they need more phosphorus. That's a whole other world. If I'm growing just seedlings for sale, which a lot of greenhouse operations do, that's a different story. I can grow that seedling at the same phosphorus level as most horticultural crops. But if I'm growing a tomato or a cucumber and the like, they need much higher elevations of phosphorus for a longer period of time, because they have different requirements than what we're looking for. You're trying to, first off, it's a longer growing crop. That's the first stage. You need a much more developed root system to support the plant as it goes forward, and that phosphorus becomes more critical for that fruit development than what we would normally look at in our trade in the horticultural business when we're trying to grow primarily flowers. So it's a different need for a plant than what a greenhouse vegetable operation would be using.
Okay. Another viewer wants to know, why is it not also too high for geraniums? And I'm guessing they mean the fertilizer? Okay,
so that's always a challenge. I think I know what he's referring to as. A geranium, we learned this years back with geraniums, there's a thing called micronutrient toxicity syndrome, excuse me for that phrase. And what that is, geraniums are a challenge in that if I grow a geranium at too low of a pH, it starts storing micronutrients. It picks up all the micronutrients that are in that soil solution. And the leaves store that micronutrient over a long period of time and start causing phytotoxicity to the leaf. It starts to look like you got spider mites on your plant. And it's just because you've got too much micronutrients stored in that leaf over time. But if you don't elevate too high over time, but more importantly, keep your pH higher, like I say at 6 or 6.5, which what geranium loves, I don't have to feed excessive micronutrients, and it's not going to be picking anything more up than it normally would at a 6.5 pH. Where the challenge is when the pH gets too low on a geranium, it's getting way more than it needs, whereas at 6.5, it's getting just enough what it needs. So it's a kind of a balance that you're having there. with a geranium versus, say, earlier I talked about like a calabaco or a pansy or a petunia. It's an interesting balancing act, but geranium is a very good indicator plant if your pH is too low and your micronutrients are too high.
Okay. You have mentioned micronutrient packages a bit throughout this presentation. Could you elaborate on what these are and what they look like? And then also, are they water soluble and what are they called? So basically, everything about them.
Right. So we sell, I'm going to guess, probably 20 or 30 different micronutrient blends that we offer to the trade. And it has a standard package of all the things that you would expect in a micronutrient fertilizer, which would be things like zinc and boron and manganese and molybdenum and iron, etc. Those are the ones that come to my mind at the top of my head. And they're usually packaged in like a 25 or 50-pound bag of fertilizer bag, and you buy them by the bag, and then in turn you just add so many ounces or pounds to your injector tank, just like you would add your normal NPK fertilizer. So it's just something that you purchase separately and supplement to that normal fertilizer solution that you're doing presently. You could add it to the same injector tank. That's not a problem. That's your NPK fertilizer on. But it gives you that flexibility of elevating your units more so than what you would try to do with a finished bag of fertilizer. We also sell components by themselves. If somebody just wanted to buy zinc or somebody just wanted to buy iron, we do that also. But the vast majority of people buy it as a blend from us that they can go forward with that. But we have all sorts of flavors and styles that people have in the trade based on their water and, more importantly, what they're growing. So I hope that answers that question.
Okay. Another question is, does use of the chelated micronutrients justify rethinking the 3:1:2 NPK ratio? If so, what would the revised golden ratio be? And they're guessing maybe 6:1:2.
Honestly, most people today in the trade go with a 3:1:3 ratio to be specific. So, there's a fertilizer, for example, 17-5-17, which is a very common product from us, and there's other manufacturers that make a 15-5-15. So that's the most common one that we go with. The elevated nitrogen levels that we went with for a while, like I'm just going to say like a 19-5-17 or something like that. There's probably more N than we tend to need on the plant. The nitrogen is unless you're growing foliage plants, which are quite different. They have a quite different nutritional need. And foliage is something that I kind of like to keep separate from this conversation. But foliage would be the exception to the rule where they do need more N than K, and obviously compared to phosphorus. But so if I'm going with the standard application of a 3:1:3 ratio fertilizer, then it's just a function of what my minor package is in that fertilizer to address the plant's needs. We usually use a standard package with our 17-5-17, but we have all different kinds of combinations we do, and also a lot of people will buy 17-5-17 with no micronutrients in it, and then they'll have a separate micronutrient package that they purchase from us and add that as they need it rather than have us do it. So it just depends what works for each individual operation.
Okay. And you mentioned foliage plants, and the next question is actually, is this beneficial to foliage plant growers of like pothos, ivy, aglaonemas? So what would you suggest for them, a separate conversation offline?
I think that would be best offline, because we have a whole nother world that we deal with in that world, and we quite often have, for very large foliage operations, we actually make custom blends based on the individual crop. It depends on the person and the location and where they are. If they're growing on assorted materials, there's a foliage fertilizer that we sell, but quite often in the foliage trade, somebody's just going to specialize in just one specific pot-type crop, and we'll make a specific fertilizer based on their needs. And quite often what they'll do is they'll start with one and finish with something else at the end. So it just depends on the sophistication of your operation. But
okay.
The best offline would be best with that.
Okay. Well, the questions keep coming, and we've got a little more time, so I'll throw out a couple more.
Alrighty.
Another one is, do you test water and then make recommendations of which fertilizer to use?
I didn't even get into that conversation because I kind of assumed that we're all there at that stage with this world. Water is everything in our trade. We've learned that the quality of the water is going to impact that plant more than anything else that you do going forward. And when you make a decision on using a fertilizer, you have to have a water test taken that's reasonably current within the last year or two. And from that water test, then we will make a recommendation as far as what the appropriate fertilizer is. So to answer the viewer's question, yes, we do test water. We do median soil and tissue and all that sort of things also. But water tests are the key going forward with the proper fertilizer recommendation for the individual operation. So, yes.
Okay. And then I think our last question here is, what is the best form in which to apply micronutrients by foliage or to the soil?
I'm a big fan of soil application. I'm not a big fan of micronutrients to the leaf. And generally speaking, one person told me if God wanted plants to grow, to get fertilizer in the leaf, they would have put the roots in the air and the leaves in the ground. So I know that sounds like a silly comment, silly answer, but you get more bang for your buck if it's applied through the root system. And the reason is it's a longer impact on that plant if it's taken up by the root system than if you apply it foliar. A foliar application, traditionally iron is what we would usually do with foliar application, will green that plant quite nicely, but it'll dissipate just as fast. If it's done through the soil, it holds that color longer, and you get other benefits throughout the plant beyond the foliage, because plants don't send nutrients down too well, they send them up very well. So if I'm applying a micronutrient package to the soil, I'm getting everything in that plant, taking advantage of that elevated nutrient as compared to just the foliage itself.
Okay, great. And I got a message in here. Great answers to my two questions. So, yeah, you're being very informative. And just for those of us or those in the audience who, if you send in a question as I'm wrapping this up, the folks at Plant Prod will get back to you. They will get a list of emails and questions, so don't worry if somehow your question didn't get answered. So this wraps up our webinar, and as a reminder, an on-demand version of this webinar will be archived and available at the same link you used to register. So thank you all for joining us today, and thank you to Plant Prod for sharing this information with us.
Thank you very much for your help.